Okay, this is an instructional video about the glass and about the 22nd and 46-degree halos that we see in the sky. And what's happening there, and I told you before, I solved it for you. You understand that there are concentric glass spheres up in the sky. We got a sun planet, yeah, sun planet glass sky, and a moon glass sky, and the, yes, phi, I can talk, and then a 100-kilometer glass sky much lower. And so what's happening there is the sunlight is actually going through those different layers of glass and is branching out, just like if you shine a laser or light through a spectrum, it's going to divide out the colors into each one of their particular angles of wavelength, the spectrum wavelength. And so the red's going to be the longest wavelength. And so let's go into, before I do that, I'll show you that. This video really helped me out, so thanks goes out to this guy, Miss K12.
We start with our screen close to the lens, and we see the same spectrum we saw before. Here is the light passing through the lens, and up above it we see the light that's sort of skipping the top of the lens. As we move our screen away, the colors begin to overlap until at one point we see a band of white light.
Convergence.
As we continue to move the screen further away,
reversal.
We see the same spectrum that we started with, but with the colors now reversed.
Okay, that's all it is. It's just a matter of location and distance. So let's go back into Illustrator and I'll show you what I drew up here. And that's showing that top-down view, concave Earth, obviously. We have the sun, heaven in the center. Then we have the celestial sphere, that smallest of the circles there. Actually, the smallest is going to be the Primer field, way up in the center. And then the octahedron is represented by that square. The smaller circle is the celestial sphere. And then the middle circle would be the sun planet glass sphere, circling the sun and the planets. And then the biggest circle would be the moon glass sphere, which has a negative refraction to it, and so it kind of messes you up. And so I explained that in other videos. We get the sun, which is really close over here. It makes a spectrum as it goes through the glass, and there's not that much. That's another thing too, because of this area right over within area between the sun glass and the moon glass. There's not at all, almost barely any air whatsoever, and that's the dewar I told you about. So a very high vacuum state, and that's where we're going to get the secondary rainbow projected, right? You understand? That's why it's so faint. It's because there's barely any air whatsoever in this area, but just enough for us to pick up whether that air is outside of that sphere or inside. Possibly either or both, I'm not sure. But that's why it's fainter like that. And so when we look at the sun in the sky, and it's creating, we have ice crystals in the sky, and the clouds much lower. I didn't put the glass sphere, 100-kilometer glass sphere, but you understand. I can do that real quick. Let's see here. Okay, there we go. I just want to be as precise as possible. So, okay, that's the wrong one. Bear with me. Broke the flow of the whole presentation. Okay, let's just say it's higher than where it should be, but you get the idea. Alright, where was I? Oh, fuck it. I'll just make that up. I don't have my contacts in either, so it's kind of, I'm very nearsighted. Let's just make this almost transparent. Okay. So this green circle and the closer to blue circle, greenish blue circle, are two different areas within the Earth that I picked to help you understand the difference between the actual what's reversing is it's not the secondary rainbow. It's actually the primary rainbow is reversing. Right? Okay, so this would be an indication when the sun is a little bit higher in the sky and we see the 22nd and the 46 degree halo, and the red is on the inside. Understand? But when we get further away, what happens with the double rainbow? Which one changed? The primary one changed. The red went on the outside now. See, the secondary one, we have the red on the inside. So something happened with the distance and the convergence of the light. They not only converged, but they actually reversed. They went the other way, just like that man showed you with the light going through the prism, through the negative meniscus lens, and projecting like that. So we have the light emanating out like that, bending like that. Magnetism is creating the bend. It's creating the reversal. We have a reversal over here. We have the waves of the light, the way they interact with each other. That's creating the bending of the light. Look into Maxwell's equations. I'll put a link in the description box. You can understand why that's happening. And now we can understand there's something going on with the primary bow that's flipping, that's reversing. Let's move that out of here. Okay. So from the shorter distance to the longer distance, we get a reversal in the primary bow. Right. So something happening with the light emanating out of the sun, and getting to a point where we will pick up the red on the inside when we are closer to it, but when we're further away, the primary one reverses. So there you go. There's my Sundogs video I did before. So we have the sun over here, that little dot, that little white dot. Then we have the sun glass, planet glass on the inside, and the moon glass with the negative refraction on the outside. And the sun planet glass, the 22, is the one that's flipping. So we only see it's an illusion. We only see half of the celestial sphere because of the bifurcation of the bending light and the convergence in the center like that. So by the time it gets around like that, in Earth over here, we have the ice crystals in the sky that are acting as a surface of projection of the glass filtered light. And so we have the 22nd and the 46th, the helix circle with the 100-kilometer glass. We have the polarization of the light, and indicating and showing how, this is a little indication that there's an octahedron up in the center like that. All right, so it's just about distance. That's why we get the reversal like that. I just wanted to help you understand that, because it was bugging me for a while. It's like, why is that reversing like that? I mean, between what we see here, right on the inside, as opposed to what we see here, right on the outside. Plus, we get the supernumerary ones. There's some kind of lamination effect going on too, with the main rainbow. So yeah, it's about distance. It has to be. That's all it is. It's about distance. Some way in which the light is bending like that, converging. The further away you go with distance, that light that's projecting through the primary one is beginning to converge and then switch over, then do a flip. And so by the time you see it, you only really can see the double rainbow when the sun is low in the atmosphere and you're actually between the sunlight and the actual rainbow. But that's what's going on like that. And I even think that the 22nd and the 46 degree halo, I haven't really looked into it, but I can do it later. you're probably going to get a even much closer observation point. Maybe it's over here. Yeah. So we get the red on the inside over here, but we get the red on the outside for the inside over here. It just has to do with distance and location. Right. Right. I'll probably do another video about this later. Who knows? We'll see. But this explains it. It's just about distance. Mystery solved.